Hello, ladies and gentlemen. This is Mr. Green with another in a series of videos for pre-cal. We're going to be talking about graphing polynomials. Now, this week is spent doing just that, just graphing polynomials. And you're going to find at the end of this week there's a little uh, uh, document in doc sharing that you need to go out and find that is some requirements that Texas has put on us to make certain we know how to do graphing correctly. But what we're looking at today is looking at putting together some of the things we've been talking about in the past few videos, plus a brand new concept which will help us locate some points and help us do some graphing. So, first of all, if we're looking at an equation like this one right here, and we're asked to graph it and do all the things that we need to do, first thing I'm going to do is I'm going to find the y-intercepts. I put 0 in for x, and what I get left with is a -3. So there's going to be a y-intercept down here at -3. So I'll get my little pointer out here and use your little starry thing, and it'll go right there. Somewhere in there. There will be a place where it crosses the y-intercept right there. Next thing I'm going to look at is I'm going to look for my roots. And if I remember from last time, it starts negative, it changes to positive. That's one sign change. It changes back to negative. That's two sign changes. That means we have two positive roots. So if I stick f of negative x in here, this one becomes a positive number. This one is a positive number. This one becomes a positive number, but this one's negative. So there is one negative root. So two positive roots, one negative root. Okay, well, we can take that information, and the next thing we're going to do is start listing out our roots. Well, I can see that my factors of 3 are 1 and 3. Not much other than that. So positive 1, negative 3, positive 1, negative 3. My roots of -4 are 1, 2, and 4. So I take the 1, divide it by 2, and I get 1/2. I take the 3, divide it by 2, I get 3/2. Take the 1, divide it by 4, I get 1/4. And 3 divided by 4, I get 3/4. So I now have these 2, 4, 6, 8, 10, 12. 12 things that I can use, try to do some factoring with synthetic division. Okay? Trying to find the roots. So what I'm going to do is I set up my synthetic division. I'm going to try 1 to begin with. I stick the number 1 in there, bring the -4 down. -4 times 1 gives me a -4. Adding down gives me 11. 11 times 1 gives me 11. 11 plus -8 gives me a 3. 3 times 1 gives me a 3. -3, 0. Ha! Root right away. Okay? 1, 0 is one of my roots. So I will have a point right there. 1, 0. I take what was left over. No reason to go back to the original equation. Take what was left over. I'm just going to go ahead and tell you that I know there's another one at 3. -4 brought down. -4 times 3 gives me a -12. That gives me a -1 here. -1 times 3 gives me -3. That gives me a 0. So there's another root at 3, 0. Okay? So that means there's going to be a root here and a root here. So I'm looking for a negative root. Look at what I got left. Well, if I take that information and use it to find -4x minus 1, add 1 to both sides, -4x equals 1, divide by 4, I get -1/4. My final root is going to be over here at -1/4. So I found the three roots that I was looking for. Cool. Now, they talk about extremes. Extremes are the maximum and minimums. That's all it is. And here's where the new concept comes in. We're going to talk about taking a derivative. A derivative is a technique that I'm going to show you here real quickly. But what it does is it's actually finding, for lack of a better term, slope of something. Okay? So what I'm going to do is I'm going to take this exponent and I'm going to multiply it times the 4. So 3 times 4 gives me a -12. That's where the -12 comes from. I'm going to take 1 less than this exponent, so -12x squared. I'm going to take this exponent too, multiply it times the 15, 30. Take 1 less than an exponent, x to the first. Exponent 1 times -8 gives me a -8. Take 1 less to it, and that gives me x to the 0th, or just a constant 8. And there is no variable on this one, so it drops off to 0. This is my first derivative. Not that difficult a process once you learn how to do it, how to physically take the derivative. Now, I could do a lot of different things here. I'm going to go ahead and use the quadratic formula. A is negative 12, B is 30, C is negative 8. Using that, I can find my roots. Well, negative B, that's negative 30, plus or minus the square root of 30 squared is 900 minus 4 times A. 4 times negative 12 times negative 8 gives me 384 divided by 2A, negative 24. Turns out to be these two ugly looking numbers right here, but that's 2.12. That's going to be right in here somewhere. That means my maximum is going to be there. And if you work it out, it's somewhere around 9. It'll be way up here in the 9 area. Okay? And the other one's at 3. That's at like 1/3 in here somewhere. And if you work this one out, it works out to be like negative 5 in here. So you can work these out, stick those values into this original equation here, and it'll tell you what the maximum and the minimum values are. Okay? We can also take the derivative again. Okay? And what I'm going to take the derivative of was this equation right here, my first derivative. I'm going to take the derivative of the first derivative to get the second derivative. So negative 12 times 2 is a negative 24. 30 times 1 is 30. The rest of it's all going to go to 0. It's going to be a negative 24 plus 30. I can solve that, set it equal to 0. 30 divided by 24, or 5/4. Okay? That means at 5/4 right here is where it's an inflection point. That's where it's going to go from a curving inward to a curving outward. Okay? That's what that means. That inflection is happening right here at 5/4. Okay? So, having said all that, let's do some graphing. I've put the points on here. There's my negative 1/4. Here's my 1. Here's my 3. Those are my 3 vertexes. I can look at this and see a negative number as my leading coefficient. That means my end behavior on the right is going to be going to the downward side this way. And my uh, inward, my end on the other side is going to be going the other way. Oops. 6. Yeah, that's what I thought. Okay, so now that I've got those in there, I've also got my y-intercept here. I can take my little pen, I can go make certain I go through my y-intercept, down here to my minimum, back up through this point here, make my inflection going from inward to outward right there, and go through that point, back down through this point down here, and I've just graphed out this equation. Are there easier ways of doing it? Well, if you've got a calculator available to you, sure, you can use the calculator and key it into the calculator, and it will graph it out for you. Okay? You could press y equals here. Okay, my calculator is not responding to me. Okay, y equals, there it goes, and we get a negative 4x, and I'm going to be raising it to the third power. Plus 15x squared minus 8x minus 3, and I graph that, and it graphs it out, and it looks something like, you can't really see it on there, not a good graph. So what I'm going to do is I'm going to press 0 and zoom 0 and have it graph it just like that. Doesn't seem right. Did I not put the equation in right? Hang on. Negative 4x cubed plus 15x squared minus 8x minus 3. Try that graph again. Zoom 0 is for fit. Okay, helps if you'd keyed the equation in correctly. It's minus 4x cubed plus 15x squared minus 8x minus 3. And I had left the x out of it, so I wasn't getting it keyed in quite correctly. I apologize about that. I had to stop the video so I could check my math there. And then when you graph this out, it looks something like that. Now, I had to change my window parameters on this one. I had to when I fit the minimum and the maximum got so big that it just was not viewable. So what I did is I changed the minimum value to -5 so that I'd make certain I was seeing this point, and then the maximum value to 15 so that I could see this maximum point up here. And then when I graph it out, it looks like this. Now remember, what are we looking at? This minimum point here was at the point where the first derivatives were 0, and this maximum point was at where the first derivative was 0. And we're also looking at this inflection point in here being at the point where the second derivative was 0. Those are the things that you need to remember about doing these graphs. It will help you a little bit, okay? And that the intention here is to be helping you doing these graphs, especially when you don't have a calculator available to you. Okay? So, don't forget, let me know that you're in pre-cal when you send me messages so that I can make certain I get the right information to you. And I will talk to you next time I